Hello everyone, my name is Wong Jialing. Today we're going to talk about brain-computer interface, application, and challenges. First thing first, so what is brain-computer interface? Well, in this picture, the man is thinking about writing down hello, and the computer just type hello on the monitors. So what does that mean? Except that BCI is the communication system between brain and computer. It also indicates that you can control a computer with your mind. That is, the computer can read your mind. But how is that possible? That is because our brain depends on neurons to deliver message. Once dendrite receive chemical inputs, the ion channel on the dendrite open, so the charged ion will flow in like sodium and a plus. So if the charge and dendrite accumulate to threshold voltage, and it will start a chain reaction in axon. So it's called action potential that lets the stimulation propagate through axon to trigger the release of another chemical signal, thus pass down the stimulation. The human brain has 86 billion neurons, and each one sends electronic signals. Following our previous slides, after the emission of action potential, the signal will travel along the path and activate corresponding part of the body. The basic theory of BCI is we can measure action potential with implanted electrodes. Record from many neurons allowed us to decode the information and translate into correct movement. Furthermore, BCI is bidirectional. That is, we can control the brain to feel specific feeling too. Once the electrode receives signal, since the neural signal in the brain are small, and we need high-performance amplifier to amplify the signal, so the signal can be collected. Then we need to convert this signal from analog to digital, as the quantifiable data is easier to process and store. Afterwards, feature extraction is a process of distinguished key signal characteristic. We may select desired feature, like spectral condition. Where is it from? During this process, our goal is to isolate wanted information and remove noise or eyes blinking activities, etc. And we will output a feature vector very similar to the process of machine learning. And the final translation algorithm will determine the device command according to this feature vector. There are actually three kinds of application of BCI, though the quality of invasive BCI is highest, but the implementation is risky, so the target of invasive BCI are mainly blind and paralyzed patients. Semi-invasive BCI have lower risks and still high resolution, but it also needs surgery, and is used only when the surgery is necessary for medical reasons. As for non-invasive BCI, as EEG can penetrate through scalp and be measured by devices, there are lots of EEG application. So you can see that this patient is actually using an invasive BCI, and he used the technology of mental writing. He imagined holding a pen to write in his mind, and then the computer can read his mind and type words. Using this technology, he can type at a rate of 19 characters per minute, which is twice faster than previous method of showing a keyboard and let the user icing character. And other similar BCI applications include control prosthetics or control wheelchair, so that the patient can regain their loose ability to use their hand again or to speak, to see the word again. Also, Neuralink is a company founded by Elon Musk, so if you are interested in BCI, please search Neuralink and go for more information. Last challenge part at hardware and software concern, as we use really high performance IC to amplify to calculate. So the cost is really high. If we want to apply it on wearable devices, the cost will be a problem. Also, since we use BCI a lot on patients, patients are often surrounded by many electronic equipment. Will BCI be affected? And most important, the exit part, like our previous slide mentioned, using invasive BCI can get better performance, but it has higher risks. So how to trade off between risks and benefits, and also the privacy part. Using BCI also makes that some of you can be exposed to other. Do you want to let other know what you might be thinking? All these are questions that deserve a deep discussion. But what we can really sure is that BCI will definitely change the way we interact with computers. And are you get ready for this?